Okay, today is going to be an intro into the applications we'll be doing with vectors. In most cases of applications, you will be given a magnitude of a vector and a direction angle. So for example, that could be miles per hour at 40 degrees or so many pounds at so many degrees. So you're normally given these two pieces of information, magnitude and direction angle. Now to actually work with vectors and combine them, we're going to want the vector in IJ form. And that's what you guys were doing a lot with Thursday and Friday. So essentially a formula that you will use in almost every application problem is this one right here. So when you have magnitude and direction angle of a vector, to put it in IJ form, you need to do the magnitude times cosine of the angle for your I piece, your horizontal component, and the magnitude times sine of the angle for your vertical component or your J piece. So this first one is just an example of getting to IJ form. So in the problem it said we had an initial speed of 25 miles per hour and an angle of 30 degrees. So again, our formula is we're going to do magnitude times cosine theta I plus magnitude times sine theta j. So in this case, 25 miles per hour is our magnitude of our vector v. 30 degrees is our angle. So we just plug that in. 25 cosine of 30 times I plus 25 sine of 30 times j. Now here's where if you ever have an angle that is on the unit circle, so 30, 45, 60, 90, 135, 120, 150, so forth, any of those angles, keep your answers exact. So if we think back to our unit circle, cosine of 30 degrees is root 3 over 2, whereas sine of 30 degrees is 1/2. So our final answer will be 25 root 3 over 2i plus 25 over 2j. And that is the vector in IJ form that represents 25 miles per hour at 30 degrees. So now getting into how we can use this. So in this second case, we have an example of two different vectors. So two different forces acting on the same object at the same time. We want to find out what the resultant of those two forces is. So first off, we have our two vectors. Vector v is a magnitude of 8 and an angle of 80. So we have 8 cosine of 80i plus 8 sine of 80j. And now since these aren't exact values, we can just go ahead and put them in your calculator. So we have 11, looks like 0.11. I'm going to go 3 decimals. 3i plus 8 sine 80 is 7.878j. So that's our vector v. Now we're going to do the same thing for w. We have 11 cosine 160i, 11 sine 160j, and then make sure your calculators are in degrees, and if we plug that in, get negative 10.337i plus 3.762j. So there's our two vectors. Now to find their resultant, we just add them together. So we legitimately do v plus w, add the i's, add the j's. So for i's, it's going to be 11.113 minus 10.337, and we get 0.776i, plus for the j's, 7.878 plus 3.762, and we have 11.64j. Now the second part of the question says, what is the direction angle and magnitude of the resultant vector? So after you get this resultant, now think back to those formulas. We want to find the magnitude, switch colors. We want to know the magnitude of v plus w, and that's just the square root of a squared plus b squared type that in a calculator. And you should get 11.666 for the magnitude. And then for the direction angle, your formula is inverse tangent of B over A, so 11.64 over 0.776. Again, type that in calculator. And you should get 186 degrees. Forgot what I was rounding to. So now whenever you do this direction angle, make sure the angle makes sense for where the vector is. Like for example, this V plus W was a positive horizontal component of 0.776, positive vertical component of 11.64. So that vector is going to be in the first quadrant, which means that 86 degrees makes sense. So your ending answer is you have your resultant vector, you have its magnitude, you have its direction angle. So now use this to apply it on the problems throughout the rest of these notes.